Hi, my name is Megan Harlow and I'm a student at Kettering University studying mechanical engineering. But I don't want to talk about that today. Instead, I'm going to talk about something that's more important in my opinion, something that is shared by everyone everywhere. It's part of the common human experience. I'm talking about stars. More specifically, I'll be talking about the red giant, supergiant phase of stars. The reason I would like to talk about stars is that I think it's important to understand how they work and operate rather than just to use them to guide us in our daily lives. So before I get to the red giant phase, I'm going to talk about the stellar evolution leading up to that phase. Stellar evolution is basically just the fancy word for the life cycle of a star. So in the beginning, stars start out as part of a nebula. Nebulae are basically these clouds of dust that occupy various spaces of the universe, mostly in the interstellar regions. These nebulae consist of gas, dust, hydrogen, helium, and a few other ionized gases. For the most part, they are just hydrogen and helium and some dust. After the star is born, it enters into the main sequence stage. This is the stage of a star's life where it is stable. It is the longest stage. It can last anywhere from 100,000 years to 100 billion years. So it's really long and it's really important. During this stage, the gravitational compression forces are counterbalanced by the fusion reactions that are occurring as the hydrogen atoms are fused into helium atoms. So the star remains the same size and emits a lot of light. So after the main sequence, the star enters into the red giant supergiant phase. The distinction between giant and supergiant is based solely off of the mass of the star. The stage begins whenever all of the hydrogen has been turned into helium, so there's only helium left in the core of the star. Because there is no more fusion reaction occurring, there is no forces outward to counterbalance the gravitational compression forces that are pushing inwards, so the star begins to collapse a little bit on itself. Because of this, gases in the center are being compressed, and whenever you compress the gas, the temperature is going to rise. Eventually, the temperature will get so hot that the helium will fuse into carbon, and this will create another fusion energy reaction that pushes outwards, counterbalancing the gravitational compressive forces to such an extent that the star will expand to a size larger than it ever started with. After a while, the energy will start to fade away, and then the gravitational compression will come back in and the star will compress again. Eventually, the temperatures will get so hot that the fusion reaction will occur again, and so the star will then be left in a process where it is expanding and contracting all the time. These expansions and contractions are referred to as pulsations. So thank you for listening. I really appreciate you taking the time to take me into consideration, and I hope that I can be a science ambassador. Thanks.